Today we're starting Chapter 13, and in Chapter 13 we're going to be solving equations. Again, we haven't solved equations in a while, and the type of equations that we're going to be solving are trig equations. So what we have, or what we'll be given is an equation, and our job is to find the angles. And usually the angles are called theta. So we're going to be finding theta that solves the equation that we've been given. So I'll just give you an example of a very simple, excuse me, Algebra 1 problem that you've solved many times before. If you want to solve this equation for x, 4x plus 3 equals 5, all you have to do is subtract 3 from each side, and you get 4x is equal to 5 minus 3 is 2. Divide both sides by 4, and x equals 2 over 4, which reduces down to 1/2. So that's something pretty easy. You've done a lot. Now what we're going to do is solve a very similar problem, a very similar equation, but this time we have to solve it for theta, not for x, but for theta. And we have to find all of the angles that satisfy this equation between 0 and 2 pi, which is 360 degrees. So what we're going to do is solve 4 sine theta plus 3 equals 5. Well, sine theta can be thought of just like an x, just like you thought of the x over here. 4x plus 3 equals 5 is the same. It's a similar type for sine theta. And you can just imagine that that could be an x. So what we do is subtract 3 from each side, just like before, and we get 4 sine theta equals 2. Divide both sides by 4, and sine of theta is 2 over 4, or in other words, 1/2. So it's the same type of thing, but what we have here is sine of theta, but we don't want to know what the sine of theta is. We want to know what this actual angle is. So now the next step after this is we have to solve it for theta. We have to ask ourselves what angles have a sine that's equal to 1/2. Well, first of all, we notice that 1/2 is a positive number, and sine is positive in quadrants 1 and 2. So we're going to get two answers out of this. We're going to get a quadrant 1 answer and a quadrant 2 answer, because that's a positive number. Now we have to find a reference angle. Well, the reference angle, hopefully you remember what angle has a sine equal to 1/2, but if you forgot, you can change the mode on your calculator to degrees mode and do second sine. Remember, it's second sine of 1/2, and your calculator will tell you 30 degrees. Well, these angles have to be in radians because I asked you between 0 and 2 pi. So 30 degrees is the reference angle, and we're going to turn that into radians. So remember 30 over 180, math frac. So we'll put 30 degrees, but we also have to call it pi over 6 because that's radians. And so in quadrant 2, or quadrant 1, the angle is the reference angle, which is pi over 6. And in quadrant 2, well, what we have is we have a reference angle of 30 degrees. So in quadrant 2 we have, we'll do the work down here. Quadrant 2, we have 180 minus the reference angle, which is 30, and that equals 150 degrees. So 150 degrees turned into radians, remember it's 150 divided by 180, math frac, and it's 5/6, but we have to put a pi over the top of that, so 5 pi over 6 would be the quadrant 2 angle. So those are our two answers to this problem. Sometimes the angles are not our special angles like 30 or 45 degree multiples, so we're going to be using our calculator just like I did before to get a reference angle. Then we have to decide which quadrants our answers are going to come from, and then we get the final answers after we either subtract or add to 180 or subtract from 360 depending on the quadrant. So now we're going to be giving our answers in degrees instead of radians. So what we're going to solve is 3 tangent of theta minus 4 is equal to 5 tangent of theta minus 1. Well, if you can imagine, this tangent of theta is like an x. So this is just like solving 3x minus 4 is equal to 5x minus 1, but the x is equal to the tangent of theta. And it's a little bit faster if we just use x's. It just makes our writing a little bit faster. So let's solve this one right here. And focus this a little bit better. All right, so what we're going to do is we're going to subtract 3x from each side and add 1 to both sides. So we have negative 4 plus 1 is negative 3. 5x minus 3x is 2x. And so what we have now is you're going to divide both sides by 2. So x is going to be equal to negative 3 halves, or negative 1.5 as a decimal. You can leave it in fraction form or you can change it to a decimal. It doesn't matter. So what we can do now is we can take this value, because we would get the same thing if we solve the equation over here. You add 1 to both sides, subtract 3 tangent of x from each side, and you're going to get tangent of x is equal to negative 1.5, or negative 3 over 2. So now we have to get a reference angle, because we want to solve this not for tangent of theta, but we have to figure out what theta is. So our first job is to find a reference angle. And to find a reference angle, you do second tan, not negative 1.5, but positive. Remember, reference angles, you have to put a positive in your inverse. So 56, and it says round to the nearest degree up here. So this would be 56 degrees as the reference angle. Now, because tangent is negative, and we're looking at all students take chemistry, tangent goes negative in quadrants 2 and 4. Because we're looking at this value right here, the tangent of theta is a negative number. So we've got quadrants 2 and 4 here. And so now we have to get a quadrant 2 angle with a reference angle of 56. To do that, we're going to say 180 minus 56. So 180 minus 56 is 124 degrees. That is our quadrant 2 angle. 124 degrees, not 1240. Hopefully you can read that okay. So our quadrant 2 angle. And then our quadrant 4 angle, to get a quadrant 4 angle, we subtract from 360. So 360 minus 56. And 360 minus 56 is 304. So 304 degrees is our quadrant 4 angle. So those are our two answers. Now the next part of this says round theta to the nearest tenth of a degree. Oops. So what I'm going to do is I'm going to just go back to my calculator, and to the nearest tenth of a degree it was 56.3. So 180 minus 56.3 is 123.7. And 360 minus 56.3 is 303.7. That's just in case they ask us to round it differently. And now what we're going to do is round the thetas to the nearest minute. So what we're going to do is go up to this angle right here that we got when we did the second tangent of 1.5. And to round this to the nearest minute, you do second angle, option 4 DMS, and this is 56 degrees, 18 minutes, and 35.757 seconds. Well, because the seconds are greater than 30 seconds, this rounds this up to 56 degrees and 19 minutes. That's the reference angle. So if I want to take 180 minus that reference angle for our quadrant 2 answer, we want to convert that to DMS. So we do second angle, option 4. We're going to convert that to DMS. And we have 123 degrees, 41 minutes, and 24 seconds. So that keeps it as 41 minutes, 123 degrees and 41 minutes. All right, so now what we're going to do is we're going to subtract 360 minus this angle right here. This is our reference angle, 360 minus the reference angle, and we're going to take that, whoops, we're going to do second angle, convert that to DMS, and we have 303 degrees and 41 minutes. So that's our quadrant 4 answer, 303 degrees and 41 minutes. That's just a DMS. You might want to write that down, DMS from calculator. Over on the next page, we have a reciprocal trig function. Sometimes we'll have a secant or a cosecant or a cotangent in our equation. And what we need to do is solve this like we regularly would. And then at the end, we're going to take the reciprocal, or in other words, flip both sides of the equation. That's at the very end. And what I mean by that is 8 secant theta minus 2 is equal to 10 plus 2 secant theta. And that's the same thing as, and it's a lot quicker if you write it like this, but you don't have to. This is the same thing as 8x minus 2 is equal to 10 plus 2x. It just saves a little bit of time if you write it like this. So if you subtract 2x from each side, and you add 2 to both sides, 8x minus 2x is 6x. The 2's cancel. 10 plus 2 is 12, and the 2x's will cancel. So 6x equals 12. Divide both sides by 6, so you get x is equal to 2. Or in other words, the secant of theta is equal to 2, the value that we got for x. Well, if the secant is equal to 2, you will flip this. If you flip the secant upside down, you're going to get the cosine. And if you flip 2 upside down, 2 is the same thing as 2 over 1. So if you flip the secant, you get the cosine. If you flip 2 over 1 upside down, you get 1 over 2. And that's what we're going to solve. So if you have one of these reciprocal trig functions, just go through the normal process, and then at the very end, flip it upside down. So if the cosine of theta is equal to 1/2, and you forgot what angle has that cosine, you can just do second cosine of 1/2, and your calculator will tell you 60 degrees. Now we have to have the answer in radians this time. Just be careful how I ask it. So the reference angle is 60 degrees, or if we wanted to turn this into radians, 60 degrees is pi over 3 radians. Now this cosine is positive 1/2. So because it's positive, it says our answers are coming from quadrants 2 and 4. So or 1 and 4. So we got a quadrant 1 and we got a quadrant 4 answer. Well, in quadrant 1, theta is the same thing as the reference angle. So we have pi over 3. That's quadrant 1. And in quadrant 4, we do 360 minus the reference angle, 60. 360 minus 60 is 300 degrees. And if we change 300 into radians, 300 divided by 180 math frac will give us 5/3, or in other words, 5 pi over 3 would be our second answer. Here's our next one. On your own, it says, so what I'd really like you to do is just turn off the video for a minute and try to solve these on your own and see if you get the answer that I get after you turn this on and follow my process. So it would be great if you could try this. It just make your skills a little stronger if you did it on your own. So shut it off. Now I'm going to do this. So we have to subtract 3 square root of 2 from each side. 2 square root of 2 minus 3 square root of 2 is negative 1 square root of 2. That is the 2 cosine of theta is equal to that. And if you divide both sides by 2, you come up with cosine of theta is equal to negative square root of 2 over 2. Oops, I could have written that right here. So this time the cosine is a negative number because it's negative 2 square root of 2. So we have a reference angle. If you forgot the reference angle for square root of 2 over 2, you can always do second cosine of the square root of 2, get out of the radical, divided by 2. And the reference angle is 45 degrees, but we want the answer in radians. So 45 divided by 180 math frac will give us pi over 4 radians. But because cosine is negative, all students take chemistry says our answers are coming from quadrants 2 and 3, because that's where the cosine is negative. So in quadrant 2, 180 minus 45 is 135 degrees. And if we change 135 into radians, 135 divided by 180 math frac will give us 3 pi over 4. In quadrant 3, it's 180 plus 45, which will give us 225 degrees, but we want our answer in radians. So 225 divided by 180 math frac will give us 5 pi over 4. So those are our 2 answers to that question. And then another one on your own if you want to try this one. This is, I'm going to turn these into x's. I didn't do that last one. I could have, but I didn't. So this is just like 3 parentheses x minus 1 equals negative 4. It's the same type of problem. So the first thing I think I would do is distribute the 3 through the parentheses and get 3x minus 3 equals negative 4. And then I would add 3 to both sides and get 3x equals negative 1, and then divide by 3 and get x equals negative 1/3, or in other words, the sine of theta is equal to negative 1 over 3. Well, this is a negative number. And because it's negative, we have to go through, well, it doesn't matter if it's negative or positive. We always have to go through the all students take chemistry. And where is sine negative? Sine is negative in quadrants 3 and 4. So now, well, I think I can fill this out, quadrants 3 and 4. Now we have to get a reference angle. And remember the reference angle, we just do second sine of 1/3, positive 1/3. Second sine of positive 1/3 will give us our reference angle. So it's 19.47 degrees. To the nearest tenth of a degree, it asks us, would be 19.5 degrees. That's the reference angle. And to the nearest minute, all we have to do is the answer, second angle, option 4 DMS. And 19 degrees, 28 minutes, and 16 seconds. Well, 16 seconds keeps that as the 28 minutes, so we have 19 degrees and 28 minutes to the nearest minute. Now we have to go into quadrant 3 with that reference angle, and in quadrant 3 we have 180, to the nearest tenth of a degree first, so we have 180 plus 19.5 degrees, and that will give us 199.5 degrees as our quadrant 3 answer, and 360 minus 19.5 degrees. That's quadrant 4, 340.5. This one is 360 minus 19.5, which is 340.5 degrees to the nearest tenth. And now what we want to do is we want to get this to the nearest minute. So I'm going to do 180 plus, and then I'm going to pop up to this reference angle here. And then you have to do second angle, convert it to DMS, 199 degrees and 28 minutes. And then I'm just going to pop up here and do 360 minus that reference angle. 360 minus that reference angle, DMS, 340 degrees, 31 minutes and 43 seconds. Rounds this up to 32 minutes because this is greater than 30 seconds. So this would be 340 degrees and 32 minutes rounded. And that's it for today. See you tomorrow.